Today, we all see some kind of image that basically looks exactly like this. It's not the exact thing, but it's still a nuclear fission reactor. We see this when you're either coming in through the highway on 230 or just sitting on campus looking out your window. We see 3 Mile Island, a nuclear fission reactor located here right in the river of Middletown. So, when you look at this, you sometimes will probably ask, oh, what's going on over there? What safety precautions? I know it's a nuclear power plant, but what do they do in case of emergencies or like safety to protect us from it? So today, what I'm going to do is talk a lot about the form of fission reactions in nuclear power. Now, that's one of two main types of nuclear power. The other being fusion, which, if you want a good example of it, is to walk outside and go ahead and look at the sun, which is constantly doing a fusion reaction of hydrogen atoms creating helium atoms. Now I'm going to be discussing fission reactions, partly because it's one of our main sources of energy in the United States and the world. So, according to Andrew Karam, research in nuclear fission began in the 1930s when Lise Meitner and Otto Hahn first showed that uranium atoms could be made to break apart or fission after being shot with neutrons. After this research was done, most of our research on nuclear power went into plutonium manufacturing for the war, for World War II, excuse me. But after the war ended, there wasn't any need really for nuclear weaponry, so they realized that the amount of energy that's put out by a nuclear fission reactor is some 10 times better than any kind of chemical energy, and also a lot cleaner. So the next step for them was to introduce fission reactors as a way of civilian energy and also military energy, which we know and see in things like nuclear submarines. Since we started doing it for civilian work, we wanted to go and make it a little easier to make and give easy ways to give examples for the world to understand how it works. So according to the Encyclopedia of Environment and Society, nuclear reactors have 7 main parts. These include systems and parts, which are the atomic core, which is right over here, the moderators, which are going to be kind of around this in the shelling here, control rods, which is basically your fuel source right in the center there, coolant system, which is these tubings right around here, and then also includes all of the cooling towers and the condensing cooling water. The pressurized vessel, which is basically this container right in here that's lined with the moderators. Then we have our biological shield, which is, again, this moderating shield, this containment structure right here as well, which it controls the biological to keep radiation in and act as a biological shield to keep workers and people around the area from being exposed to radioactivity. What happens in the reactor here is what we call a controlled reaction. This is where you have your control rods, right, which is located here, have what are called uranium pellets inside of them. These pellets are filled up into these rods, and to control the reaction, you're controlling how much fuel is being put into your reaction. So when you need more fuel put in, they raise the rods up and the pellets come out and are hit with the neutrons and continue the chain reaction. When you need less, you don't put as much in and you don't raise the tubes as high. These moderator shields are normally something along the lines of graphite or heavy water, which is a simplified term for deuterium, which is a form of hydrogen atoms that is created using tons and tons of water at a time and processing it through chemical reactions to get a suitable material that can deteriorate at a certain rate with radioactivity, so you know how much radiation is coming in from the core. Now, what I'd like to talk about next is the benefits, drawbacks, and the safety that most fission reactors are using nowadays. The benefits of the nuclear fission is it's exponentially better than any kind of chemical heat energy source such as oil and things like that. It outblasts any kind of form of renewable energies like winds and things like that. It has an abundant and very, very cheap fuel source, which is uranium 235 and uranium 233. And it has absolutely no CO2 footprints at all on the Earth, meaning there's no greenhouse gases being thrown up into the air, creating more global warming. Some of the drawbacks to nuclear power, though, are that you have nuclear byproducts such as nuclear waste, and that we have to store in certain areas that can sometimes have 100 to 100,000 years of half-life, meaning it takes that long for it to become non-radioactive and safe to handle by hand. This can come into effect of the future generations of our children, our children's children, having to deal with all the storage and all that taking up its space. But like I said earlier, some of the safety features that we have on our fission reactors are amazing, with their containment fields and are protecting us from the core, and also protecting the core from outside attacks in terms of like electrical storms and things like that. So next time you go and you take a look at the nuclear reactor across on 3 Mile Island, you know a little bit more about what's going on over there, the safety features that they have, and that you know you'll be safe even if some things do go wrong. Thank you.